Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Hello friends, here it is given. Suppose an electrons can be placed either of two configuration configuration 1, electrons are placed on the circumference of a ring of radius r, so that distance between two adjacent electrons to be same. Configuration second, n-1 electrons are uniformly distributed over the ring and one electron at its center. We have to find the value of n for which energy of second configuration is less than that of first. Second, for the given value of n, consider any one circumference electron call it E naught. How many other circumference electrons are close to E naught than that of central electron? Let us hear the solution. Let we have a system of E naught, E1 and En electrons. Then total potential energy of the system can be defined as summation E square upon 4 pi epsilon naught Ri Rj. Here you may write E square upon 4 pi epsilon naught summation of Ri Rj. This can be defined as just a moment, I have to correct. N times summation of I is equal to 1 to n minus 1 1 upon R O I. Now configuration 1, Rij having the value 2R sine of j minus I upon n into pi. So n by 2 summation I is equal to 1 to n minus 1 1 upon Roi having the value n minus 1 upon I is equal to 1 into 1 upon 2R sine of j minus I upon n into pi. So on solving it, you may write n upon 4R summation of I is equal to 1 to n minus 1 cosec of I upon n into pi. So energy of one configuration you will get E square upon 4 pi epsilon naught n upon 4R summation of I is equal to 1 to n minus 1 into cosec of I into pi upon n. Now for configuration 2, from the center of the ring we divide the circle into n minus 1 angles having value 2n minus 1 upon, sorry, 2 pi upon n minus 1. So energy of the system in second configuration we can measure E square upon 4 pi epsilon naught n minus 1 upon 4r summation of I is equal to 1 to n minus 2 cosec I into pi upon n minus 1 plus n minus 1 into r. Now we have to form the table for initial energy and energy of one configuration to other from electron n is equal to 2 to 16. See here, table for U1 and U2 for n from 2 to 16 and U1, U2. For n is equal to 2, U1 is 0.5, U1 is 1. For 3 electron it is 1.73 and 2.5. For 4 electron it is 3.83, 4.73. For 5 electron it is 6.88, 7.83. For 7, 16.13, 16.96. For 8, 22.44, 23.13. For 9, 29.92, 30.44. For 10, 38.62, 38.92. For 11, 48.58, 48.62. For 12, 59.81, 59.58. For 30, 72.35, 71.81. So this quantity is matching for our result. This is important. So we can say n should be less than 12 for U2 to be greater than U1. Now second part we have to solve. It is as we given in part A, the distance between any two electrons EI and EJ in the circumference two are sine of J minus I upon n into pi if I is equal to 0 and n is equal to 11, Rj will be 2r sine of j pi upon 11, else E naught will be at a distance r from center. We have to find the value of j for which j for which 2r sine of j pi upon 11 to be less than r. So 2r sine of j pi upon 11 means sine of j pi by 11 is less than half, that is j by 11 pi is greater than pi by 6 or j by 11 pi is greater than 5 pi by 6. Hence j will be less than 11 by 6 or greater than 55 by 6. This value will be true for j is equal to 1 and j is equal to 10. So two electrons are closer to E naught than the central one. That's all. Thanks.